Today, we're doing end behavior and zeros for polynomial functions, and I'm going to show you the part that everyone gets wrong. Here's a question. If I hand you a degree 5 polynomial and never let you graph it, can you still tell me which direction it points on to the left and which direction it points on the right? Well, you can every time. Two numbers in the equation give it away completely, and I'll show you exactly which ones. Think of it like a roller coaster blueprint. Before an engineer builds anything, the blueprint already tells you which way the track launches and which way it lands. Nobody has to write it first to know that. A polynomial is the same. The degree and the leading coefficient are the blueprint. They tell you where the graph launches from and where it lands before you ever plot a point. And the zeros? Those are just the spots where the coaster touches the ground. Keep that picture in your head because we're going to come back to it for every example. Here's the intuition before any formula. There are really two separate questions, and students blend them together, which is where the confusion starts. Question 1. Where does the graph go far to the left and far to the right? Off the edges of the graph? That's controlled by the 2 degrees and the leading coefficient only, nothing else. Question 2. Where does the graph actually touch or cross the x-axis in the middle? That's controlled by the factor, and how many times each one repeats. Keep those two questions separate in your head, and the whole topic gets a lot easier. Now, here's the full real table for end behavior, and it only depends on two things. Is the degree even or odd? And is the leading coefficient positive or negative? Even degree, positive leading coefficient. Both ends go up, like a smile. Even degree, negative. Both ends go down, like a frown. Odd degree, positive. Down on the left, up on the right. Odd degree, negative. Up on the left, down on the right. And separately, multiplicity. If a factor's exponent is odd, the graph actually crosses the x-axis there. If it's even, the graph touches it and bounces back without crossing. That distinction shows up constantly on tests. First example, degree. That's odd. Leading coefficient is positive 2. So off the rule table, down on the left, up on the right. Lock that in first, before we even factor anything. Now to zeros. This is where most people mess up. Watch this step. We test small integers using the equation directly. Try x equals 3 to 2 times 27 minus 3 times 9 minus 11 times 3 plus 6. That comes out to 0, so x minus 3 is a factor. Divide it out and the rest factors into 2x minus 1 and x plus 2. So our zeros are 3, 1 half, and negative 2. Each one appears only once. Multiplicity 1. So the graph crosses the x-axis cleanly at every single one. Harder one. A quartic with a leading negative sign. And this is the trap I want you to see coming. Degree 4. That's even. Leading coefficient is negative 1. So both ends point down. A frowny shape, not a smile. This is where most people mess up. Watch this step. Don't try to factor a degree 4 expression head on. Substitute u equals x squared and it collapses into a normal quadratic. Negative u squared plus 5u minus 4, which factors into negative u minus 1, u minus 4. Substitute back and factor the difference of squares twice more, and you get 4 clean zeros. Negative 2, negative 1, 1, and 2. Every one has a multiplicity of 1, so the graph crosses at each one. But remember, both ends still point down, because that came from the degree and the leading coefficient alone, not from the zeros. 3 traps. I see all 3 constantly. 1. Forgetting the negative sign on the leading coefficient. That single sign flips the entire end behavior, and it's an easy thing to skim past. 2. Assuming every zero crosses the x-axis. It doesn't. Check the multiplicity first. Even multiplicity means the graph touches and bounces back instead of crossing. 3. Mixing up which parity does what. Even degree means both ends do the same thing. Odd degree means the ends are opposite. Say it out loud if you have to. It's an easy swap to make under time pressure. Now, pause the video, try these three. I'll wait. Number one is straightforward end behavior. Number two is testing whether you can read multiplicity straight off a factor form without expanding it. Number three makes you do both steps back to back. Let's walk through it. Number one, degree 4, even leading coefficient, positive 3. So both ends go up. Number two, factor x plus 1 squared means x equals negative 1 with a multiplicity of 2. So it bounces off the axis there. The other factor is multiplicity 1. So it crosses cleanly at x equals 3. Number three, factor out negative x from negative x cubed plus 4x, and you get negative x squared minus 4, which gives zeros at 0, 2, and negative 2. Degree 3, odd leading coefficient negative. So up on the left, down on the right. If you got 2 on 3, that's generally solid for a first pass. Okay, here's what I promised you at the start. There's one sentence stem that covers end behavior on any free response question. And if you memorize the structure inside a specific answer, it works every single time. As x approaches positive or negative infinity, f of x approaches and you fill in positive or negative infinity. Because the degree is even or odd, and the leading p of coefficient is positive or negative. Fill in those four brackets correctly, and there's no partial credit ambiguity left for any grader to take a point off. That's genuinely the whole skill expressed in a one sentence. So to recap, 1. End behavior comes only from the degrees parity and the sign of the leading coefficient. 2. Zeros come from the factors, so always factor before you say anything about where it crosses. 3. Multiplicity tells you to touch versus cross. Odd crosses, even bounces. 4. Use a sentence stem on free response. It covers the whole skill in one line.